Oh no, it broke. That's anticlimactic. Okay, we'll do it like this. Another semester means another Arduino project. And the task is fairly simple too. Just make something, and for the second project, make it cooler. And while those rough guidelines are pretty much very simple, and I can just, I could just resubmit this in. And it still pretty much works, just 50% of the time, But that's a little too simple. It's a little too easy. But it's not anything new. I'm not only cheating the system, but I'm also cheating myself. Like when life gives you Arduinos, you make something. Now what can I make? For a little less than half a year now, I've been wanting to make a music box. Like some kind of programmable drum that will spin onto a note comb and then play some music for you. So you don't have to do anything. It's automatic and analog at the same time. But I don't want to make any ordinary music box either. I want to be able to have 3 programmable drums that are all tied together and then connected onto like some kind of gearbox so that one motor can spin all 3 of them. Why is that important? Well, on the back here, I want it to be able to rotate the whole thing. So the general idea is I have a music comb right there, and then one drum plays some music. Woohoo! The problem with that, it's a small drum, so it's not going to be able to play very much. So I have 2 options. One is to just have it play a very short snippet of a song. Then this giant wheel back here can spin the whole apparatus around, switching the drum to a different song, or have one drum with one snippet of the song and the rest of it on the other drums. The problem with that is getting the rotation timing right, so I'm not going to do that. I'm going to have short snippets of one song on this one, another song on this one, and another song on that one. I think that will be still pretty cool. How am I going to do it? Well, my professor was kind enough to give me an Arduino Uno. I then ordered myself this little motor driver. And finally, I have this old boombox with an optical drive, which I'm going to use the motors for. Just so I could have more options, I'm going to salvage some of these momentary clicky buttons. Click, click, click. And nothing's happening, which is good because I didn't even program it. And because this is just a prototype, I'm not really gonna dive too deep into this code. So here it is, and it's gonna go right into here. And before I finish putting this mess together, I just want to point out that earlier I attached the momentary buttons weird. Now it's like in the right configuration where one side of it is low, the other side of it is high. So in its off state, it's always high to the Arduino, but once I push down the button, it gets shorted to ground, and then it's like, hey, what's going on? Count. And one more thing, I accidentally ordered the wrong motor driver, which is fine because all I had to do was just switch around some of the wires and change up the code a bit, and boom. Now this mess of wires and whatever this is just a proof of concept of me using an Arduino to power a motor driver to power the motors. I'm not expecting it to work all the time. 75% is honestly good enough for me. And so far, it's only been working 75%. Now, what this is my version of a fan. Now, on YouTube, there's this great series about fan showdowns, and I thought it would be cool to use one of the top running fans, the OBB by Craftcentric, mainly because, hey, it looks super cool. Just gonna throw that on there. Now, what I did here is give it 3 modes. The first mode is a single speed. Wow, look at that, it spins. The second mode is, you guessed it, an even higher speed. And for his third mode, like any other fan out there, it has to oscillate, right? Down here, I have a worm gear set up to make it oscillate. You know, I always thought fans should oscillate at 360 degrees. It's been 3 weeks. And in those 2 weeks, I was able to add a desk to my room, build a chair, and get nowhere with the project. I did present it though, which naturally went, it didn't work. I mean, it kind of did.
Yeah,
like
for
the
some
fans,
reason,
it was only
turned
had
them
both
hard.
on at
The,
max, and I thought it was just
great
turns off
idea.
the other
Give it
one,
full
like
charge.
360
One or the other.
thing.
I don't know,
Yeah, that
maybe
worked too.
overcome
It's
the
just,
resistors
it didn't
and
work
just short
simultaneously.
everything out.
Fine, it's whatever, because that's not the main point of the project. The whole main part of the project is still the music box. This is a relatively cheap music box from Amazon, and I already broke it. The coil spring in this little housing over here, I kind of spun it too far the other direction. I guess it just dislodged, disengaged, and it doesn't wind up anymore. It still makes like a pretty tune, like listen. So yeah, it's pretty fun. From this, I'm just going to be taking this little music comb here. Now, before designing and printing and making anything, there are 2 things that I have to calculate for. Pretend that this is an 18-note music comb here. I have to figure out which notes correspond to each of the 18 pins on the note comb. The reason why I can't pull up a data sheet for this is, interestingly enough, whenever a manufacturer is selling one of these music boxes, they're most likely going to send you a custom cone designed for the song that it comes with. Then the next problem. I have to figure out the revolutions per second for the motor. The reason why that's important is because then I know its maximum rotational speed to then calculate how many gear rotations and gear reductions I have to make in order to get about 30 seconds of playtime. Then from there, I could design how big the cylinder has to be, print everything out, put it all together, and hopefully it will work out. So let's start plucking. Since my little sister was briefly into ukuleles just enough to buy a tuner with it, it finally came in handy. Just the tedious task of picking each pin and noting down whatever is most consistent. Just plucking and plucking and plucking for 8. And this is the layout for my specific comb. The next part comes to a little bit of math, and I have to figure out how many revolutions per second the motor is spinning at say 75% max speed. The reason why I'm running it at 75% is that it gives me a little bit of leeway both ways. In my opinion, it's a good point to be at, because if I need it to go faster, I could just increase it to say from 75 to 80 to 100%. Of course, I could always slow it down if the tempo is going too fast. Now what I did is use a state-of-the-art slow motion camera to record the motor spinning at 75% with a piece of tape on it. That way I could drop it into iMovie, slow it down even further, and read off every single time the tape passes one certain point. Of course, the timestamp on iMovie isn't going to be perfect, and it's not actually going to be 13.6 seconds. For that reason, I'm going to turn the video back to normal, drop it into the sketchy website over here, and then take that time value. Knowing how great I am at counting, I actually did this 4 times, and taking the average of that actually came out to be 100 rotations for each duration of the video, which actually came out to be 1.7 seconds. So 58 revolutions per second. Insane. What's even crazier is that I want each song to last about 30 seconds long. So that means that for 30 seconds, that motor is going to have to spin around 1,764.71 times, while the cylinder with the music on it rotates a mere 1 times. That is a gear ratio reduction from 1,764.71 to 1. That's fine and all. I think I could design a gearbox that will handle that. The problem is, I think how much noise will be generated from this. Like a lot of my projects, the answer is always, we'll see. But yeah, I think the next part is to first design a gearbox that will handle this kind of gear reduction ratio, and then design a cylinder with the music that I want put on it. Look at this dongo. Look at how cute it is. Look at his tiny little eyes. Did you know that this is actually 3D printed? Oh. I was not supposed to be one of the objects flying out of that transition there. It was supposed to be one of the barrels filled with copper pins, which was then supposed to be preceded by a bunch of other B-roll, but I started to run out of time. It got to the point where pulling an all-nighter was barely enough, and that was without recording anything. But I did get an A on the project, so that means it's finished. Actually, it's been done for about 3 weeks now, and I am just so ready to finish this video and get this behemoth off of my desk. Don't get me wrong though, this music box is still pretty cool and probably has the most moving parts that I've ever made. The only problem is, it doesn't work. It will still spin and the gears will drive. There's just too many problems that just won't do. So instead of a B-roll and then a cool demo, I'm going to finish explaining the concept and then a cool demo, because regardless of its operability, it's still pretty dang cool. As you can see, I 3D printed 3 different barrels programmed with their own songs, carefully mapped to the notes of the cone. Now, I thought about printing the notes directly onto the barrels, but then I thought that it wouldn't be very sustainable. So that's why I decided to print them with holes, shoved copper wires into them, snipped, and called it a day. The barrels are placed in between the shift gear and this triangle thing. There's just a few millimeters of material that acts as an axis for the cylinders to rotate on. The center of the triangle is then hollowed out for the driving gear that simultaneously, oh, I shouldn't do that to the phone, that simultaneously spins all 3 cylinders. As explained earlier, I went from a 1600 to 1 gear ratio. This is so that the tiny 5-volt motor can combat the high friction, multiple gears, as well as the 3-barrel assembly. The specs of the gearbox is shown here. Explaining it could get wordy and confusing. Basically, I had a few sets of 60 and 15 teeth gears for a 1:4 gear ratio, then a set of 75 and 15 teeth gears for a 1:5 ratio. The motor has 15 teeth and the final gear has 75 teeth to drive the 3 cylinders. This was also done with consideration that changing the size and radii of the gear will also change the spacing between their 2 centers, so we have to keep that constant. All in all, there's 1 15 teeth main gear, 2 60 to 15 teeth, 1 60 to 15 special teeth gear, 1 75 to 15 special teeth gear, and 1 75 teeth driving gear. This adds to 3 4:1 ratios and 2 5:1 ratios for a total of 1600 to 1 ratio. Now the left rail is actually being stabilized by this piece of wood, carefully placed to be aligned with the main housing, while the right rail actually goes through the triangle, past the cylinders, and right into the expo marker for extra stability. The expo marker is actually the main axis for the shift gear as well. Originally, I designed the shifting ability with a worm gear in mind. That way, while it's not rotating, I can make the structure stiff at a pre-programmed location, since the barrels will cause some kind of torque once they strike the pins. This did not work out, however, since I do not have any motors strong enough to drive the worm gear. So in a panic, hours before my deadline, I decided to rip into an old printer that I found on the side of the road to steal this huge motor and belt. I filed the center of the gear teeth away so that the belt wouldn't slip off, and to my surprise, it worked. Here is the full assembly with the music comb attached to a piece of wood for amplification. I'm not even gonna try to go over the code nor the wiring because frankly, I don't really remember it. Just these 2 momentary switches that leads to some pins on the Arduino that then controls this motor driver to spin the spinny parts. Everything is then powered by these 2 rails leading up to this USB cable that can also be plugged into this power bank here. Playing the songs won't be great, mainly because the music comb has lost about 33% of its notes. But this is what the ending to Sessionwa Butayoro sounds like on the world's first triple barrel music box. To change songs, simply apply the shift button. I did not program any stopping points to the shifting gear, not only because I was running out of time, but also because I knew what I have made It's just not going to work out. Though if I had to add stopping points, I would have used a spring and contact system on the side of the shift gear. Once it passes a certain position, a circuit is then completed, telling the Arduino to stop the motor. I would make a unique system of springs and contacts corresponding to when a certain barrel is at a position. Then I would fine tune it with delays because of human error and stuff. Either that, or I would have invested more time learning about the transparent strips that allows a printer to know its rotational location. I would steal that along with this optical reader and then slap it right onto the shift gear because, you know, I kind of mutilated that printer. Though it does sound pretty cool with both motors on simultaneously. Am I going to fix any of these issues? No. Mainly because I'm content with what I've made thus far, and I know that I can make it work with, you know, a little bit more work. However, I would much rather move on to other projects. If anyone would like to complete my work, however, I can of course upload my wiring diagram, code, as well as my STL files. Just ask nicely and let me part with some advice. I would try to utilize the worm gear system or something else other than the belt, mainly because it adds quite a bit of length to the overall project. In designing the gears, I would have gone back and used larger gears, a finer nozzle, or a resin printer. The 0.4mm nozzle as well as the PLA filament that I was using couldn't really print out fine detailed gears, which I'm pretty sure led to the high friction that I experienced. I tried greasing it up, but that still wasn't enough. I guess I should have played with the tolerance as well because there was noticeable wobble between the gears. Earlier in the video, I calculated the gear ratio at a 75% motor speed. In the end though, I ended up using the topped motor speed because 75% was just not enough to drive the gearbox. Granted, all of my motor problems probably would have been resolved if I just use a stronger power source. But I'm, como se dice, lazy. I should have included the ability to tie the triangle and the shift gear together with a through rod. That way, I wouldn't have to cut and tie the strings every time I needed to troubleshoot something. Also, there should have been more parts designed with 3D printed material. Using wooden components just became too inaccurate. Some parts were just not straight at all and everything just became loose. As you can see, the shift gear wobbles a little, but since the comb has nodes separated by the millimeter, even the slightest horizontal inconsistency will change the songs drastically. Even that wouldn't have saved the project though, since I solely cut the copper pins myself, trusting that human eyes and hands are good enough to precisely cut down to the micrometer for 100 notes for each barrel. With the factors of the pins being different heights, some being bent, the wobble of the shift gear, and the insanely small music comb, many teeth were sacrificed in the making of this video. But I think once these factors are addressed by anyone who's crazy enough to pursue this fever dream of an idea, they will truly make the world's first functional triple barrel music box. You know, according to some of my friends, it kind of sounds like the music to a horror film. So let me just plug it right in here. And then, let's see, turn this on and then that on and everything on and on.